Good afternoon, Year 12s. Hopefully you are watching this at midday-ish on Wednesday. I'm recording this on Monday, our last day on site. I want to briefly talk to you about part 3 of Unit 1, Dynamics, which is essentially Newton's laws of motions, 1, 2, and 3. A bit of work on force body diagrams, and some momentum work, which we'll also cover in Year 12 mathematics as well. We'll do the momentum work when we come back in the new year, so I want to quickly go through Newton's laws with you and the force diagrams, right? So there's some, if you could download this information I've put up onto Google Classroom, it's your notes basically for this unit, and I just wanted to read through it. It's quite wordy, I'm not going to fib, right? But there's a lot there on Newton's first law, which says that everything will remain at constant velocity or stationary unless acted upon by an external force, right? You need to be able to reproduce that definition in an exam, etc. There's a little bit there about terminal velocity, which of course we're already familiar with, so make sure you read through the notes there. And then a little bit about Newton's third law. Whenever one body exerts a force on another, the second exerts an equal and opposite force on the first, or as in layman's terms, to every action there's an equal and opposite reaction. What's critical about Newton's third law is that the forces are acting on different bodies, okay, and we'll talk about that later. So I'd like you to read through all of that, please. Newton's second law is the most mathematical one, and it tells us that the force on an object is its mass times its acceleration. And of course, we've done some work on SUVATs. We know that V equals U plus AT, and if you rearrange that, you get A equals V minus U over T. If you substitute that into that formula, it becomes force is the rate of change of momentum. And again, we'll talk about more about that in a minute. So one thing I'd like you to do to start, there's some very, very basic questions here on Newton's second law, where you have to play around with force equals mass times acceleration. So if you could please pause this right now and have a go at those 5 or 6 questions there. I will post the solutions in about an hour's time. Okay, so press pause now. Right, and then continuing, we have a little bit about the definition of weight. It's mass times its gravity. I'd like to read through that, please. Thinking about the reaction forces on bodies against gravity, so please read through that, right? I know this is a bit dry off me, but I just wanted to read the notes. And then we get on to some good stuff, what we call a free body diagram. The free body diagram shows only the forces acting on the object in question, not those acting on the other objects, right? So this will probably be new to you. So have a look at that free body diagram there for the box, okay? So it doesn't mention the bloke pushing the box, but it does talk about the resistance of the box from the table or the floor, whatever it's against, the forward force movement of the box, the weight of gravity acting on the box, and the reaction force of the earth on the box. Okay, so that's called a free body diagram, and we're going to practice them a bit more now. Any F1 fans will like this question. It's basically, it's about the forces acting on a Formula One car. Okay, so I'd like you to have a good look and read through that, please. And then we'll get on to some questions, right? So here's your standard question-y type stuff that you'd be used to seeing in my lessons. Continuing reading through that, please. There's that part I was on about there. Force is the rate of change of momentum, mv minus mu over t. You'll have to use that equation quite a bit in A-level physics. A little bit more there on Newton's third law, and I'd like you please to have a look at the example there. The diagram shows an object being held up by someone's hand. The object is a teapot. Draw the forces acting on the teapot. What can you say about the size of those forces? Are these an example of Newton's third law? So have a little think about that, please. Write down your answers if you've managed to print off your bit of paper. If you haven't, that's fine. Do it on a bit of scrap paper. We'll figure it out later. Press pause, please. Thank you. Right, and coming back to that teapot question then, the explanation now is on this page. So you can read through that at your leisure. I won't have to go through it for you.